Welcome to conversion from base 10 to other bases. In this lesson, I'll be walking you through how to convert a number from base 10 to other bases. What do we mean by conversion of number base? It simply means to change from one base to the other. Let's look at example 1. We have to convert 134 in base 10 to a number in base 6. What we need to do here is to divide the 134 through repeatedly by 6. Draw your table, and then the next thing is to take the number 134 to the right hand side and then the 6 to the left hand side. So what you're doing here, you're doing 134 divided by 6. Okay, now let's see. Can 6 go in 1? 6 cannot go in 1 because 1 is less than 6. So what we need to do now is to engage this next digit, which is the 3. Let's combine the 1 and 3 together. So 1 and 3 now becomes 13. Now say 6 in 13. If 6 goes in 13, it will give us 2. So that means 6 times 2 is going to give us 12. So 13 minus 12 for us to get the remainder there. So our remainder is 1. When we subtract 13 minus 12, we have 1 left. So the next thing to do now is to engage the next digit, which is 4. So we combine this 4 and the 1 together, and that will make it 14. So we now say 6 in 14. How many times will 6 go in 14? 6 will go in 14 2 times. And then what is remaining? Okay, 6 times 2, that gives 12. 14 minus 12, that's going to give 2. So since there is no other digits left after this 4, then we just say remainder the 2. The next thing now, we are dividing through repeatedly by 6. So we have to divide this 22 also by 6 again. 6 in 2, 6 cannot go in 2. So we combine these two digits together, 22. How many 6 will go in 22? 6 will go in 22 in 3 places. So 6 times 3, that will give 18. So 22 minus 18, that will give remainder 4. Okay, the next thing to do now is to also divide through again. Divide this 32 by 6. So let's do that. 6 dividing in 3. One thing you notice here, can 6 go in 3? 6 cannot go in 3. Since 6 cannot go in 3, all you need to write down, and you know that 3 is the last number here. So since 3 cannot go in 3, we only say 0. Okay, and then the next thing is the remainder will be this value that we have left, which is 3. The remainder will be 3. Okay, let me try to explain that. 6 in 3. Since 6 cannot go in 3, we have to put 0 here. And then what is left here will now be this value, which is 3. That will be our remainder. That means for us to get our final answer now, we'll have to draw an arrow from the bottom to the top to trace it, so that we will have something like this: 3, 4, 2. That means our 134 in base 10 in base 6 will give us 3, 4, 2. That's the final answer. Let's look at the example 2. Convert 248 in base 10 to base 8. Okay, draw your table, and then put your 248 to the right hand side, and then the 8, which is the base, to the left hand side. So what you're doing here, you're dividing 248 repeatedly by 8. Okay, so can 8 go in the first digit, which is 2? 8 in 2, 8 cannot go in 2. So we take this 2 and the second digit, which is 4, and that will give us 24. So 8 in 24, that will give us 3. 8 times 3, and that is 24. So we have 3 there. There is no remainder there. So let's take up the next digit, which is the third digit, 8. 8 in 8, that will give us 1. You can see now 8 here is the last digit. So what we need to do here, we just say 31 remainder 0. Since there is no other, we don't have any number here that is remaining. When we say 8 divided by 8, that's 8 in 8, no other number. That's the reason why we have the remainder 0 there. The next thing now is to divide again this 31 that we got from here by 8. So how many 8s will go in 31? 8 will go in 31 3 times. That's 8 times 3. That will give us 24. So 31 minus 24, that's going to give us remainder 7. Okay, that's remainder 7. Then the next thing now, this 3 now, we need to divide it by 8. So 8 divided by, pardon me, can 8 go in 3? 8 cannot go in 3. So what we need to do there, we just write 0. Since 8 cannot go in 3, we write the last one, which is 0, and then we write remainder, the value that we have here left, and that is 3, remainder 3. So all you need to do now is to draw your arrow upward to trace the number, and then if you trace the number upward, you see that we have 370. So our answer for conversion from 248 in base 10 to base 8 will be 370. You can cross-check your work using your calculator. If you look at base 8 is in calculator, that's oct in calculator, and there's also base 10, that is dec on your calculator. So you can do that with your calculator. Let me show you how to do that. Okay, the first thing you're going to do now is to convert your calculator to number base, and to do that, go to your mode on your calculator, click on mode, and then you see something like base. There is base n, there is a number here. All you need to do is to press the number, press 2. You might not have this on your calculator, but after pressing the 2, it might take you to the number base direct. I'm going to press 1 here. The base showing right here is octal, that's base 8. So since we are dealing with base 10, we want to convert from base 10 to base 8. So let's put it on base 10 first. If you look at dec, there is dec here, and that means if I press this place now, I'll put it on dec. And there is hex. If I press this one, I'll put it on hex. This is being binary. If I put it here, I'll put it on binary, and the oct. So we're only dealing with dec and oct since we are converting from dec to oct. So let's put it on dec. We are converting from dec. So let's type in the number 248, and then having typed the number like that, then just go to the oct and press oct, and then you see the number 370. You can see that it's tallied with our answer, so we are correct. Let's look at example 3. What is the expression of 58 in base 10 to base 2? So draw your table, and then put your 58 at the right hand side and 2 at the left hand side. So we are repeatedly dividing 58 through by 2. So can 2 go in the first digit? The first digit here is 5. 2 in 5, how many times will 2 go in 5? And that is 2. So remainder what? Remainder 1. So 2 go in 5 2 times. 2 times 2, that gives us 4. 5 minus 4, that is 1. So remainder 1. So we have 1 there. And then the next thing now is to take up this 1 with the next digit, and the next digit is 8. 1 and the 8 together, that will make 18. So we have 18. We now say 2 in 18. How many times will 2 go in 18? 2 will go in 18 9 times. So since this 8 is the last digit there, so 2 goes in 18 without any remainder, so we write remainder 0. Okay, the next one now, we also have to divide this 29 by 2. You know, we are dividing repeatedly by the base 2. So 2 in the first digit that we have here is 2. 2 in 2, that will give us 1. And 2 in 9, 2 will go in 9 in 4 places to remain 1, remainder 1. So you know 2 times 4 will give us 8. So 9 minus 8, that will give us 1 as a remainder. The next thing now is to divide this 14 that we got by 2 again. So how many 2 will go in 14? If you go to your 2 times table, you know that 2 will go in 14 7 times. That's 2 times 7 will give 14. So 2 will go in 14 7 times without any remainder. So we write remainder 0 since there is no any remainder there. And then the next thing, we also have to divide this 7 by 2 again. So 2 in 7. How many times will 2 go in 7? That will be 3 times remainder 1. If you remember the 2 times table, 2 times 3 will give 6. 7 minus 6, that will give 1. So that's where we got the remainder 1 from. The next thing, this value 3 here, we also need to divide it by 2 again. So 2, how many times will 2 go in 3? 2 will go in 3 one time. Remainder 1. You know 2 times 1 is 2. So 3 minus 2, that gives 1. So that's where we got the remainder from. And the next thing now, we have 1 remaining here. So we also need to say 2 in this one. Can 2 go in this one? So if 2 cannot go in 1, so what we need to do there is to write 0 as the last one there. Since 2 cannot go in the last digit, the last number here is 1 and 2 cannot go in it, so we write 0. Then our remainder will now be what is left here, this 1. So our remainder will be remainder 1. The next thing to do now is to trace our arrow from the bottom to the top, and then following the arrow we'll have 1 1 1 0 1 0. So the conversion of our number 58 in base 10 to base 2 will give us 111010. Now let's use our calculator to check our answer if it's correct. So if you look at the question, 58 is in base 10, we're to convert to base 2. So that means we have both in our calculator. Put on your calculator. Make sure your calculator is on base 10. So if your calculator is not on binary, all you need to do is to go to mode and then press 2. So this might not show in your own. Okay, the next thing now is to go to your decimal, and that is it, your deck. So that's where would you type in the number now, 58. After typing the number, then press this bin. This bin stands for binary, and binary is base 2. So press this. You can see right here that we have 111010. It tallies with your answer, so that means we are correct.